Here is our last property of logarithms, the change of base property. And this says that if we have any two bases, b and c, so b and c are positive numbers and they're not 1, at any positive number x, the log in one base of x is the log in the other base of x divided by the log in the other base of the first base. And notice, since b is not 1, the log of b is not 0. So that means that we really can divide by it. This is the change of base formula for logarithms. It's going to turn out to be very, very useful because there will often be circumstances where there's one specific base that we want for all of our logs, and we want to rewrite all other logs in terms of it. So let's show why this has to be true. I'm going to use a new symbol y to represent the log of x, the log base b of x, which means that x is b to the y power. Okay, so there we have an equation. If we take the log base c on both sides, we get that the log base c of x is equal to the log base c of b to the y power. Okay, but now if we use the log of a power rule, we get that the log base c of b to the y is y times the log base c of b. So that means that y times the log base c of b, that's this expression, that's equal to the log base c of b to the y, which is equal to the log base c of x. Okay, but then if we divide both sides by the log base c of b, we get that y is, well, it's the log base c of x divided by the log base c of b. Okay, but then y is equal to this expression, and y is also equal to this expression. That means that this expression and this expression have to be equal because they're both equal to y. And that gives us our change of base formula. Okay, I said we want to have this change of base formula because there are occasions when we want to work with a log in a certain base. At the moment, our primary purpose for this rule will be to calculate logs on the calculator. I told you when we first talked about the common log that all the math classes teach this, so all the calculators go ahead and don't have a log in any base button. None of the calculators have a log in any base button, so all the math classes have to teach this. We're in this sort of vicious cycle. This is not the primary purpose for the change of base rule. We will need this in calculus, but it is a purpose that we're going to put it to since we have it. So let's see how we would do this. We want to find the log base 7 of 212. The change of base rule says we can do this with the log in any base, but I'm going to choose the common log. I'm going to say this is the log base 10 of 212 divided by the log base 10 of 7. Throwing that into the calculator, we'll have the log of 212 over the log of 7. And that's about We want to round to 3 decimal places, so this is about 2.753. And we can actually check that by rewriting an exponential form. If this is true, then if we take 7 to the power 2.753, is that about equal to 212? Let's try it. 7 to the power 2.753. Yeah, that's real close to 212. So that actually works. Again, this is going to be our main use for the change of base formula in this class, but it's not the case that we're just learning the change of base formula because our calculator is deficient. It's just a convenient use for this formula since we have it anyway.